good morning and happy Tuesday. We are going to check our math homework from Monday. You will notice that I already have my dots on my coordinate plane. This was a tricky one to number. Remember, we had to look at our X and Y's and decide how to number our number lines. The X-axis we counted by twos. And then we found out for the Y-axis, the pattern we were going to use is basically counting by halves. Half, 1, 1.5, 2, 2.5, 3, 3.5, 4, and so forth. So you will notice I have here one dot in quadrant 2 over at negative 14, positive 2. I have one right here on the y-axis at 0, positive, it looks like that's positive 3.5. We have one in quadrant 1 over here at positive 14, positive 2.5. We have two dots here in quadrant 3, negative 4, negative 1/2. And then we also have negative 8, negative 4, and one dot here in quadrant 4. We went over positive 6 and down 3.5. Okay? The hardest part here about plotting these points is figuring out how to number our scale. Okay, so let's go ahead and we are going to move over to lesson 18. Okay, so lesson 18 now is looking at distance on the coordinate plane. So we have here like a street sign showing us how far these towns are. It says 4 friends are touring on motorcycles. They come to an intersection of 2 roads. The road they are on continues straight and the other is perpendicular to it. The sign at the intersection shows the distance to several towns. Draw a map diagram of the roads and use it in the information on the sign to answer the following questions. So the first thing we need to do is we need to make our map or diagram. Perpendicular lines are lines that look something like this, which is like our coordinate plane. Well, we're coming up to the spot here. I'm going to go ahead and make, and you might want to wait till I've made mine so you can watch. So here's my y-axis. And I'm going to put my X actually down here. I'm not going to put it in the middle. And I will show you why. Okay, so we'll label this our X and Y. So we're coming along this direction here. Okay, we've come here to the intersection. We will notice that Albertsville is 8 miles to the left. So as we come up here, we're going to put 8 miles right here for Albertsville. Let's put an A for Albertsville. Then we know that Blossville is 3 miles going straight. So right here at the 3, we'll put B for Blossville. Cheyenne is continuing this direction, but it's all the way up here at the 12. 12 for Cheyenne. And then we have Dewey Falls, which is going this direction, and it is 6 miles this way. Okay, so we have our little picture here to help us understand. It says, what is the distance between Albertsville and Dewey Falls? So we're looking at the distance from here to here. Well, let's think about this. If I know that from here to here is 8, and from the origin over here is 6, I'm going to add my 8 plus 6, and I come up with the answer, 14 miles. Okay, so if I wanted to drive from Albertsville all the way through the origin over here, it's going to be 14 miles. All right, let's look at the next question. The next question says, what is the distance between Blossville and Cheyenne? Well, let's go up here. Here's Blossville, and here's Cheyenne. So I have to find out the distance from here to here. Well, I can't add them together because I didn't cross over the origin. I basically went from here. If I went from 3 to 4, 5, 6, 7, 8, 9, 10, 11, and 12. So the best thing for me to do is probably take my 12, which is where Cheyenne is, subtract the 3, and see what I come up with. What's 12 minus 3? Okay, my answer is going to be 9. So there's a distance of 9 miles. Now if I look here, I was here at the origin. These 3 miles here are the ones that we're wanting to get rid of to find out how far it is. Okay, and our last problem on this page, it says on the coordinate plane, here's my coordinate plane, what represents the intersection of the 2 roads? So where my 2 roads here intersected, right here, what represents that? Well, that would be considered our origin. So let's go down here and we will write origin. Okay, when you're ready, you can go ahead and turn over to the next page. All right, so example 1. Here it says consider the points -4, 0 and 5, 0. What do the ordered pairs have in common, and what does that mean about their location in the coordinate plane? All right, so let's look at these two. What do they have in common? We've talked about this before. Well, it looks like to me what they have in common is they have a 0 in their y coordinate spot. So let's go ahead here and write that both of their y coordinates are 0. Okay, now we have to find out what does that mean about their location in the coordinate plane. Well, for me, I have to see, I'm a visual learner, so I'm probably going to make here just a little tiny coordinate grid like this, coordinate plane here. And I would say, well, if I had to go backwards 4 up 0, I probably would go about right there. This one says over 5 up 0, so I would go here. Well, if I notice, they are not inside one of the quadrants. They are actually on the x-axis. So it says, what does that mean about their location? I'm going to say that both points lie on the x-axis. Okay, it says, how did we find the distance between two numbers on the number line? Well, if you remember, this from here to here is -4, right? So it is 4 places from the 0. That's the absolute value. How far is this one? This one we came over 5. So this is 5 places over. So we're going to take and add our 4 plus 5 to find out that these two dots are actually 9 units apart. Now, the other thing that we can always do in case you have a hard time seeing that on here is if you ever have an extra coordinate grid, whether it's when you want to look back on some old pages or if you have something copied off, if you would look here, if I go -4 up 0 over +5 up 0, I can always look on my paper and count 1, 2, 3, 4, 5, 6, 7, 8, 9. They are 9 units apart. Okay? All right. So it says use the method to find the distance. Well, we just did that up here. And so if you think about it, this was at -4. Well, we know that the absolute value of -4 is 4. This was over at +5, and we know that the absolute value of 5 is +5. So we added those two numbers together to get their distance. Okay, let's move down to the next example. Okay, example 2. Here's our ordered pairs. What do the ordered pairs of the endpoints have in common? And what does that mean about the line segment's location in the coordinate plane? All right, well, let's look carefully. What do they have in common? This time they have both of their x coordinates are 0. Okay, so we noticed that they both had 0 here for their x. Once again, we want to know what does that mean about the line segment's location. Well, I'm going to make a little picture right here for me so I can visibly see where they are. This one says I'm going to go over 0, down 6. Over 0, down 6 means I'm probably going to be down about right there. This one says I'm over 0, down 11. So I'm going to go even farther down here. It looks like I'm going to be down farther down there. Okay, well, if you notice, they are not exactly in one of the quadrants. Now they are on the y-axis. So we'll say that both points lie on the y-axis. Okay, both points lie on the y-axis. Find the length of the line segment described by finding the distance between its endpoints, 0, -6, and 0, -11. So once again, if I wanted to, I could pull out my graph paper and I could go over here and let's see, it says over 0, down 6, which would be right here where my finger is. And this one says over 0, down 11, which means I would be right here. So my dots would be here and here. I want to know what the distance is. Well, I could count the squares. 1, 2, 3, 4, 5 spaces are in between them. Or I could do this. Well, I know that -6, the absolute value of -6 is 6 places. And the absolute value of -11 is 11 places. So how far are these two apart? Well, I'm going to take 11 and I'm going to subtract 6 to find out they are 5 units apart. Okay, some of you are going to be able to mathematically solve these, and some of you might want to pull out, like I said, your graph paper so that you can actually count the spaces in between them. Okay, let's move on to our next problem. Example 3. Consider the line segment with endpoints -3, 3 and -3, 5. -5, sorry. It says, what do the endpoints, which are represented by the ordered pairs, have in common? What does that tell us about the location of the line segment on the coordinate plane? So look very carefully at our ordered pairs, and what can you tell me they have in common? Well, if you look carefully, they both have the same x-coordinate of -3. So we'll say both points have an x-coordinate of -3. All right, so I'm going to actually move our textbook over here a little bit, and we're actually going to look here at my coordinate grid. All right, if we recall, we have these 2 points. I'm going to graph them here on my coordinate plane, -3, +3. So if I go over -3, +3, I'm right here. And then the next one said, if you guys look in your math book, it's -3, -5. -3, -5. It said that this is a line segment. Okay, so what do we notice? Well, we already noticed that our x is -3 on both. But if you notice, I have here a vertical line, and the vertical line crosses at the -3 on my x-axis. Here's my x-axis. Okay, it crosses my x-axis, which we just said, they have the same x-coordinate. Okay, so when we write the description of when it says, what does that tell us about the location of the line, we're going to say that we have a vertical line that crosses the x-axis at -3. Okay, remember, if I'm going too fast for you, remember to pause the video so that you can keep up, so that you understand what's going to happen, because we are going to be having a test at the end of the week. Okay? All right, the last thing here says find the length of the line segment by finding the distance between its endpoints. Well, what's nice is if you have a graph paper like this, we can actually look at them and we can count them. So if I line this back up here, if I count the units, okay, let's see if I can get the glare off here a little bit. You can actually see it goes 1, 2, 3, 4, 5, 6, 7, 8. I can actually count that they are 8 units apart. Find the length of the line segment. Well, we did, and so we're going to say 8 units. If you don't have graph paper handy to do that, you would probably draw something like this and make a dot. Okay, -3, +3 would be up here, and -3, -5 would be about down there. Okay, very similar to what I have here for my picture. Well, if this is the x-axis and I went up 3, I know from here to here is 3. If this went down 5, I know that that's 5. So I had to add 3 plus 5 to get my 8 units. Okay, well, let's move down to the next problems. Okay, so once again, if you have a coordinate grid to draw on, it kind of is a little bit helpful. If you find one that you can copy off at home, if you notice I kind of stuck it inside the cover of my math book, and I kind of use that with my dry erase marker so that I can erase it. Let's look at my points. This is -3, +4. So I'm going to plot the point -3, +4. And if you notice, my next point is -3, +9. So I'm going to go here to -3, +9. I have to find out how far apart these are. Well, I can count 1, 2, 3, 4, 5 units. And so my answer on my paper is going to be 5 units. I also will notice that my line is what kind of line? It's a vertical line. Okay. Well, let's see here. I have a common x coordinate. Okay, so we'll have to remember that. See if we can find a pattern. And how did I get 5? Oh, I looked at these two numbers, and it looks like we subtracted to get 5. 9 minus 4 equals 5. Okay. Let's look at the next one. Okay. The next one says I have to plot points of 2, -2, and -8, -2. Okay, so let's go over 2, -2. Over 2, down 2, right there. And then we had to go backwards, 8, down 2, right here. We have to see how far they are apart. Well, if you notice, look at this. They both crossed. They crossed an axis, so we're going to have to be able to know that this from here to here is 8, and from here to here is 2. So we're going to add those two numbers together, and we get 8 plus 2 equals 10. So let's go back over here, and we'll say 10 units. Let's see, this time we have y coordinates that are the same. Y coordinates that are the same, and remember our line went horizontal. Okay, so hopefully the more we do this, the more some of you will start seeing the patterns and be able to figure out how to solve this without looking at a picture. Now, if you notice, how did I get 10? Well, here I had a +2 and a -8, so I had to find the absolute value. The absolute value of 2 is 2. The absolute value of -8 is +8, and so I added those two together. Let's look at the next one. I see that the x coordinates are the same, and we found out if the x coordinates are the same, we know we have a vertical line. Let's see if I can solve this without. Well, this time I know if I have a coordinate grid like this, and if I go backwards 6, down 6, and I go backwards 6, up 1. Oh, look at this. Looks like I went over an axis again, so I'm going to have to add those two together, the 6 and the 1, to get 7. Let's see if I was correct. Let's go plot these points. Okay, so I'll erase this. All right, my points were -6, -6, which is right here. And my other point was -6, +1. Let's count. 1, 2, 3, 4, 5, 6, 7. 7 units, so we were correct. Okay. Solve our last two. Okay, let's look and see. What do we have in common? It looks like the y coordinates are the same. We found out when the y were the same, we're going to have a horizontal line. Horizontal line. Let me make a quick little picture for myself and see if I can figure this out. -9, +4. -9, +4 would be about right there. -4, +4 would be about right there. Oh, I did not cross over an axis. So I'm going to guess that because I didn't cross over, I'm going to have to subtract. The absolute value of -9 is +9. The absolute value of -4 is +4. If I subtract them, I'm going to go for 5 units. Let's see if Mrs. Houck's correct. So let's go back to our paper. The 2 points were -9, +4, -9, +4, and -4, +4. All right, how far apart are those? 1, 2, 3, 4, 5. I was correct. Okay, go ahead and see if you can solve this one for me, the last one. Pause your video and check to see if you were able to solve this. All right, let's look to see. That's our x coordinates are the same. If our x coordinates are the same, what did we find out? We should have a vertical line. I have to make a little picture here. So if I go over 0, down 11, it's going to be down here. And if I go over 0, up 8, it's going to be way up here. Looks like my line is crossing the x-axis, so I'm going to have to add these two together. So let's see, if I have 11 plus 8, I have 19 units for my vertical line. Let's check to see if I am correct. All right, 0, -11, and 0, 8. Here we go. 0, -11, and over 0, up 8. Whew, that's a pretty big line. From here, from the origin down here is 11. And from the origin up here, it is 8. And so I am correct. 11 plus 8 equals 19 units. Okay, remember, if you weren't able to solve my trick this way, you can always find some graph paper like this, plot the points, and count the boxes. Okay, and that will help you. Make sure you know that this is a vertical line and this is a horizontal line. All right, well, I hope you guys have a great Tuesday, and I will see you again on Wednesday.